All right, if I was going to pick one topic, one skill, one subject that you would really master in this course, this is it. And as we go along, you'll start to see why that is. But for right now, I hate to say it, but just take my word for it. This is the skill. You want to get this skill down. I said fractions is the most important skill. That's for mathematics writ large. That's for all of mathematics. Whether you're doing this or trigonometry or I don't know, accounting, math, whatever that is. But this skill within this course, algebra, this is a skill you want to get. And you've probably done this before, but I'd like to look at this as like a new day, and you're just doing this for the first time. So let me write a problem down of this type. Let's see. Now, let me tell you something up front. Most numbers are not whole numbers. But for this problem right here, I would like to start out with an example. Where the solution will only involve whole numbers. And the reason I stopped there for a second is you saw me hesitate. Well, I'm making this problem up very specifically so that happens. Because I'm going to talk about why these problems are so important and how they come up in the actual real world, so to speak, in science and engineering, economics. Most of the time, the answers are not whole numbers. But I really want this to have an answer of a whole number right now because it'll help, I don't know, maybe help you see what's going on a little more clearly, not to have to look at some unpleasant fractions. So let's see here. Okay, this is one problem. And what you see here are two equations, and there are two unknowns. There's the two equations. We don't know what x is. We don't know what y is. There are many, many, many different ways, like I said, not only to solve this, but to think about what this even means. But for right now, I'm not going to worry about any of that. We're just going to go over a way to solve this. Hold on one second. I think I hear my dog bark. No, just somebody at the door. Okay, hey. We're going to solve this by what's called the method of substitution. We're going to solve it other ways. But I really want you to learn this particular way. Some people call it the substitution method. Some people call it the method of substitution. And if you haven't done it before, you'll see why we call it the substitution method. But I want to break this down into 4 steps, 4 easy to follow steps. This is one of the very few times that on the next exam, I'm going to ask you to show your work, and I'm going to look for these steps. I rarely ever say a person has to solve a problem by a certain method. In fact, there's only 2 times that I ever insist that in all my classes. This is one of them. So step number one, pick one of these equations. It doesn't matter which one you pick. If one looks easier to deal with, pick that one. I usually just pick the first one. I don't know, it's the first one. But pick one of the equations and solve it for one of the variables. So you can pick either equation and you can solve for x or y. It's your choice. I'm just going to pick the first equation because it's first, and I'm going to solve for x. I don't know what comes before y alphabetically. So here's our first equation. Let me just write it down by itself. You don't have to do that, but let me write it down by itself. And let's solve it for x. So let's get the 4y over on that side. We'll subtract 4y from both sides. And then we'll divide both sides by 3. So there's step 1. Comments about step 1. Did I just do math? Yes, I did. But not much. if you were to find yourself reaching for a calculator on step one, or if you were to find yourself really struggling with step one, there's a very good chance you're not doing step one correctly. Now, when we get to step three, there may be a fair amount of work. So if you find yourself struggling with step three, that doesn't necessarily, it just means you're struggling with step three. But this step right here shouldn't be too bad. Very little in the way of calculation. Okay, now step two. This is the this is the substitution step. Since x equals this, it is allowable that we take this and substitute it in for x in the second equation. Now notice, I could have chosen any equation I wanted. As a matter of fact, if you don't like the order of the equations, you can switch them around. It doesn't change anything. Pick an equation, solve it for a letter. Step two is you substitute into the other equation. And it's got to be the other equation. The other equation. It's got to be the other equation. I hope I mentioned it's got to be the other equation. I'll leave it to you if you want. You can experiment. Take this, substitute it back in the equation you started with, and see what happens. And you'll see why we don't want to go down that road. It's not wrong. It just loops you back to where you started from. Okay, now let me go ahead and make this substitution. These arrows don't really signify anything. I'm just trying to call your attention to where, to what we're doing next. Markers flying all over the place here. So 5. Now, instead of x, I'm substituting this. 2/3 minus 4/3 y. Everything else, I'll leave as is. That's step 2. Important question right now. What math skills do you have to do step 2? Think about it. What math skills do you have to do step 2? I'm waiting for you to think about it. And the answer is none. You don't do any math on step 2. Did I add anything? No. Subtract, divide, multiply? No. Did I even do the distributive rule? No. Did I combine like terms? No. All I did was copy things. This 5, I copied it. I didn't do anything with it. Instead of x, I copied this, but I didn't do anything with it other than copy it. The negative side, negative, 3y equal 13, 13. You don't do any math on step 2, but if you make a typographical error, if you copy something wrong, you'll get a wrong answer. It can be incredibly frustrating, and it is easy to do. So just, I don't know, be aware of that. Now, notice what we have. We have one equation and one variable type, only y. So here's step 3, solve for y, or solve for whichever variable. If I started off solving for y, then I would substitute in for y here, and I would have only x. So basically what you do at this point is solve this equation, which is like one of the equations that we talked about from chapter 3. Okay, let's go ahead and solve this. This is nothing new, but it could be, some amount of work. So we'll go ahead and do the distributive rule. And again, this is nothing new here. And hopefully this doesn't seem too bad at this stage of the game. Let's go ahead and combine like terms. If we combine those like terms, negative 29 over 3 y. And let's subtract 10/3 from both sides. So 29 over 3. I promised I wouldn't talk about this, but I can't not talk about this. Make sure you're doing that. Like, okay, somehow or another, I was able to succeed in subtracting 10/3 from 13. So 13 minus 10/3. I did it in my head. Wow, big deal. If you've done 50 million fractions, you'd be doing it in your head too. Do it in your head, do it on paper, like I said, but make sure you do it. Confirm that's really what it is. And now let's divide both sides by this number, and we get what? By negative 29 over 3. And we get y equals -1. Now the fact that it came out nice, I made the problem up so it would come out nice. They're not always going to come out nice, but quite a few of them will in this course. It turns out that what we're really interested in is having you learn this particular procedure, not struggle with terrible numbers. Am I done? No. How do I know I'm not done? Well, number 1, I said there were 4 steps. But more importantly, I know what y is, we still haven't figured out what x is. So what's the fourth step? Take this value right here and substitute it back into the original equation. Now you can actually substitute it back into any equation you want. But what can happen sometimes is when you're working a problem, you'll have your work all over the place and you may lose track, for example, of this equation. This can be convenient sometimes. Um, but what I usually do is just come back to the very first equation. That'll be either printed in the textbook or something I wrote down. So you can't really lose track of it. So let's go ahead and take this and put it in that equation. And we get 3x plus 4 times negative 1 equals 2. And this should be pretty easy. I can't guarantee that this will be easy, but it should be fairly easy. That's negative 4. Let's add that to both sides. We'll get 6 and divide both sides by 3. We'll get x equals 2. Our solution, our answer is a pair of numbers. It tells us what x is equal to, and it tells us what y is equal to. Let me do one more example of this. Now, of course, I didn't create this method. This method has been around for over 2,000 years. I have to think a little bit about the history there. The ancient Egyptians were able to solve systems of equations. I'm not sure this is exactly how they did it, but to the best of my recollection, this is approximately how they did it. Their number system and a couple of other ways they noted things would have been a little bit different. But at any rate, look, that doesn't make this good or bad. That doesn't make this valuable or invaluable means valuable, just really, really valuable. Not valuable because it's been around for thousands of years, but it has. So you're not going to be the first group of people to be tormented with doing these problems. Now I'm going to write down a problem entirely at random. I don't want to start with bad numbers, but let's see, 5. 5's a pretty nice number, nothing wrong with that. How about minus 7y equals 1? 1, 5, 7, nothing crazy about those numbers. And how about, I don't know, 3x plus 2y equals 5. Now, what's the answer for this? I don't know, and I can't see through to the answer right away. The answer is a set of numbers. It's a pair of numbers, and it may come out really nice, but I have no idea. So let's go ahead and solve it. Let's solve the first equation for x. Let's add 7y to both sides. Divide both sides by 5. Okay, not too bad so far. I mean, I don't really know how bad it's going to get. Let's substitute this in the other equation. Get this. Excuse me, that's step 2, the substitution step. We don't do any math on that. Let's go ahead and do the distributive rule. So far, so good. I hope it's good all the way. I mean, I'm not rooting for difficult numbers to deal with. That's not what I'm aiming for. I'm just trying to make a problem in a slightly more natural way. It's still not very natural because 5, 7, 1, 3, 2, 5 are pretty nice numbers. Let's go ahead and combine like terms, these two, 31 over 5y. And let's subtract this from both sides. So 22 over 5. Make sure you double check my arithmetic. I can make careless or silly mistakes like anybody else on a regular basis. Let's go ahead and divide both sides by 31/5. How do you divide? You multiply, as always. So 22 over 31. I would have been shocked if it had come out as a whole. I wouldn't have been shocked, but because the initial numbers I chose, I chose 5, 7, 1, 3, 2, 5. Really entirely at random. I just thought, let me pick pretty easy, well, frankly, single-digit whole numbers. And we'll just let the chips fall where they may. There's y. How do we get x? Let's go back to the original equation there. So 5 times 22 over 31. Now, maybe I spoke too soon. Maybe the number's going to get a little worse here. What's this times this? 110 over 31. Once numbers get over 100, it starts getting in, like, because you're outside the times tables. A little, but who knows? But it's not the end of the world so far. 7y equals 1. Let's subtract this from both sides. It might have been easier if I had subtracted 1 and added 7y to both sides, but hey, I said, let's go ahead and do this. Now, notice already that's, depending on how awake you are or depending on your mood, you have to do 1 minus 110 over 31. I've seen people get this far in a problem many, many times. This far in a problem and stop here. Don't let this defeat you. I mean, you've gotten this far. Don't let it defeat you. I think that's 79. You should double check. Hey, don't trust me. Okay, trust me that I'm going to show you the right procedures. But, is that correct? So double check that. Wait a minute, that's not correct, is it? Negative. And then let's divide both sides by -7. So 79 over 100. Oh, jeez, 100. 227. You might want to double check to make sure that that's right. Hey, just a little brief note. This doesn't really have anything to do with this particular topic right here. So it's a little thought bubble here. How the heck would a person do 7 times 31? Well, you just use your calculator. You could do old-fashioned multiplication. To me, I think of this as 7 times 30 plus 1 more 7. And 7 times 30 is 210. And 1 more 7 is 217. So it looks like that was wrong. So I hope you're checking and knows that. I do want to show you this. I don't really think of it this way. Nonetheless, look. This is 7 times 30 plus 1. And do the distributive rule. And, that's one way you can do some mental arithmetic. Is it handy? Yeah, it kind of is. Convenient. I've been doing it my whole life. I don't really think about it too much unless I think about it specifically to talk about it. Okay, now, some good news and bad news. What's the shortcut version of this? There isn't one. That's one of the reasons I like these. These are perhaps the best sorts of problems to practice and really acquire solid skills at solving linear equations. We do the distributive rule, combine like terms, have to mess around with fractions. These kind of problems come up all over the place, and we are going to start discussing that pretty soon. Our textbook has problems like this, 2 equations and 2 unknowns. This is a great place if you go on YouTube and you just search for 2 equations and 2 unknowns and put in the word substitution. You'll get more practice problems than you could do in a lifetime. Just YouTube, 2 equations, just type in 2 equations, 2 unknowns, substitution. Autofill will beat you to it, but nonetheless, type that in. I can't vouch for any of them. Or, I could take a look at them and then vouch for them. But usually on the first screen, there's kind of a little cast of characters that I see all the time. Khan from Khan Academy is one of them, but there's a bunch of other ones. If you don't like, for some reason, one video, just go to another one. Now, they better show you this method because this is the method of substitution. I didn't make this up. This has been around for thousands of years. So if they're showing you something completely different, I would click away from that. Our textbook also shows you this. I've shown you this, but now you need to practice. I'm going to do another video on this. Let me go ahead and give you one to practice, and the next video, I'll solve it. But one more for practice is not enough. Now, if I told you how many I think you should really practice, it might scare you away, but I think that you should, what do I really think? I think you should do like 50 problems like this, because then you would just be an ace solver of linear equations. But if I said, hey, if I give you an assignment, 50 of these, you might not even do it. But I think that if you did 20 of these, it may not sound reasonable. It'll be slow going at first, but you'll really start to pick up the pace. But I think 20 is something, it's a reasonable goal for you to work towards. So that's your practice. That's like the coach telling you to practice, or your music instructor to tell you to practice, or anything you want to get good at, you just got to practice. That's really kind of the responsibility is in your court, so to speak. So let me write down 2 problems here. Now let me show you a little behind the scenes of making up. I'm going to actually tell you the answers. I don't mind doing that because I want you to go through the procedure. That's what counts here. So you're not supposed to see this, but I want you to see this. So let's suppose x is 3 and y is 5. Now again, you weren't supposed to see that, but this is, if I want the problem to come out with nice answers, this is how we pretty much have to do it, unless you're lucky, I guess. So let's say we had 7x minus 2y. Now the 7 and the 2, I'm picking easy numbers really at random. And I take it back. They're not really at random. I'm picking them in a way to make, look, I don't want the number over here to be too insanely difficult of a number, okay? So what we get, 21 minus 10 is 11. So you notice so far the numbers are 3, 5, 7 to 11. Nothing too crazy, and I really don't want them to be too crazy right now. And let's suppose we had negative 2x plus 3y. That would be what? Negative 6 plus 15. What's negative 6 plus 15? Is 9. Now you weren't supposed to see this over here, so let me erase this. So pretend you didn't see that. Work this problem. Let me just write down a problem at random and try that. So 2 problems. Next video, I'll solve these 2 problems. So here's the next one. Let's try one with some fractions. There's one, and let's make this. So here's 2 problems. Here's one problem, here's another problem. You try doing those, and I'll solve them in the next video. It'll either be tonight or tomorrow morning. But also, this is a good time. Go to YouTube, look at some examples. More importantly, if you're watching a video, say for example on YouTube, they're going to do something very similar to what I'm doing. They'll put a problem on the board, boom, hit pause, you try working it, and then you can watch them solve it. And I'm going to go out on a limb and say you can't practice too many of these. I don't think that's possible. And it's really by doing these that you start to get good at math. This is how you get, it's not glamorous. I admit it, it's not exciting. Now, next video, should I do this video now? I'll do a next video. I'll tell you how this kind of problem here and this kind of problem here is going on around you in your life almost every second. If you took this sort of thing away from the world as you know it would end. And I'll talk a little bit about why that is. That sounds like a preposterous statement, but it's absolutely true. It doesn't mean you would die, but the world as you know it, with airplanes and cars and cell phones and skyscrapers and bridges and our knowledge of DNA, that all goes away. This is not enough to give us all that, but it's a necessary prerequisite to getting all that. And I do want to talk about that a little bit. So why am I even telling you that? This is important. Please, I don't know what else I can do. Please practice that. Okay. And so I'll get your test back to you by tonight. That'll be individual. I'll be emailing you concerning the results of your test. Or I'll be messaging you back. And that's it for right now. Okay. Ready, set, go.